Hello, I think it's working now. Okay, welcome to this video. We're going to try something new. I'm going to code against the clock. So I should have a clock down here. So I'm only going to give myself 15 minutes to code. And the idea was I was watching back my previous two videos where I made some tutorials about Snake, and they took way too long. I was like going very slowly and explaining things in loads of detail and things, but still, it was taking me a long time to code. So I thought it'd be fun just to try and code more quickly, so less a tutorial than just coding fast. And hopefully, if you're wanting to learn how to make Snake, this will be the quicker way. Okay, so maximum 15 minutes. There's a scary alarm that will go off once I'm out of time. And I'm just thinking, just to make it a bit more exciting, I'm not just going to copy what I've coded before. I think I've coded Snake 3 times. The first time I can't remember what I did. The second time I can't remember, but I know that I did something different. I was doing it in 3D, so I did something definitely different to the first time. And then yesterday, when I made the yesterday-ish. I can't even remember what day it was when I made the current JavaScript version of Snake. Yeah, I do remember that, but I'm going to do it slightly different to that somehow. So again, I don't even know what I'm going to do, so it's a little bit more exciting and more kind of authentic. Anyway, let's get going. So all I've got ready is like an empty project with nothing in and a timer, right? see you on the other side. Let's do it. Let's go. The timer, is it working? No. The timer's working. Right, let's go. So I'm going to use brackets, and we're going to be doing this in JavaScript using the P5 library, but this kind of method would work, in C or Python or whatever. Programming Snake in Python would be excellent. Anyway, right. So I'm going to do it different. I'm going to do it object orientated. That's what I love. So function setup. So that's where we're going to begin, and then P5 usually has a draw function as well. So that's the draw loop. Function is where the program will start, and we need a canvas. So can I have a canvas, please? Oh, this is going slower than I need it. Right, create canvas. We'll go as big as we can. Window width, height width, height. Oh God. Interesting start. Background. Color is really important. Let's go with pink. That's what I love. Red. No green. A little bit of blue. 172 blue. There we go. Save that. Let's just see if we've got something on screen so far. Yes, we've got pink. Beautiful. Right. Okay. So I want a snake. So let's have a class called snake. No. And I need a constructor function for the snake. I'm making a class so I can have loads of little snakes if we get there. So I need a constructor, and yeah, I'm going to initialize it with a position. So we'll just say x and y, and maybe how many segments it's got. Segs, we'll call that. So it's going to have this position equals, we'll store that in a vector. So we're going to store kind of like its head in position in a vector, which is a P5 object, which you create through the function create vector. So that's going to be made from the arguments that we've passed in. So that's going to have an x and a y. And segments, I guess that's going to be an array of some kind. So this segs equals that. And then we can create those segments by saying, by having a for loop. And so we're going to have to loop around while I is less than the number of segments that we're requesting in the constructor. I'm going to iterate around, and what are we what am I actually going to say? So what we're going to push onto that array, we're going to say this segs push, and what are we going to put on there? We're going to put on a segment. So a segment really needs a it needs to be an object. So we need another object here, and I'll call it segment. I'm tempted to extend it from snake, but that would incur some complications that we don't need. So we need another constructor for our segment. I guess it would need a parent. So this parent equals, and we're going to pass in there a snake. I don't know if this makes sense yet. So this parent is going to equal this object. So when we want a new segment, we're going to have to tell that segment what snake it belongs to. So then it's also going to need a position. So that's going to be a vector as well. And maybe the constructor could receive that in a similar way to how the snake object received it. So I can see by the clock that we've had 5 minutes already. What do we need now? So that's going to be made out of x and the y. It's also going to have a size. So this size equals, let's just set that to 20, hard code that. Okay, so now I'm thinking that this position is not going to tell the snake where to be drawn. The drawing will happen through the segment. So let's make that function. So we call it a render function, and all it's going to do is draw a rectangle. So I'm going to use the p5rect function, and it's going to be at that location x and y and its size for length and height. So it takes 4 parameters, the rect function. First 2 position, second 2 length and height. Okay, and I want to be drawing from the center of my rectangles. So in setup, we just need to call this once. Say rect mode center. Okay, so we can draw we can draw a segment. It's going to have to move at some point. It's going to have to move, and the snake, we're going to have some kind of function where we add a segment, and I suppose what this position is the snake's head. That's the snake's head, and it's going to keep its segments in this array. So we want to push a segment onto here. So how many segments? So we're going to ask for a new segment, and then we construct that segment with which snake. So it's going to be this. Can I pass in this? Oh no, I don't know how to do that in JavaScript. Is it this snake? I'll just put in this. Does that refer to the whole object? Anyway, this, and then the position of the head. So this dot pos dot x, this dot pos. You know what? We could just be nice and put in the whole vector. That would be more elegant. So pos, and I'll just put v to remind myself that it's a vector. So this position equals pos vector dot x. And position dot y. Okay, so now we want to actually calculate where this segment needs to go. It needs to be behind where we've created the snake. So in fact, if I remember my previous version, we always just want to place the last segment piece, or the new segment piece, on the last segment of the tail. So that's different to when we're first creating a snake. What do we want to do? We simply want to push it onto where the head is, and then let the snake kind of unravel as it moves. Okay, so what I'm doing is saying here, iterate over how many segments we're creating our snake with, and push them all onto the position of where the head is. And hopefully they'll kind of unravel when we get the movement working. So actually we don't want to move the segments, we want to think in terms of moving the snake. Okay, so if we should we try that? So we want to say for I equals 0, do we want to move? We want to move from our last segment. So I equals this dot segs length, 5 minutes left, length minus 1. Yeah, that's going to be the last segment in our array. While I is greater or equal to 0, that's going to be the first segment, and decrement instead of incrementing over our segments. Okay, I haven't saved this for a while. So what was I doing? What am I doing? I'm moving it. So I'm going to say this segs I. So that segment, it's going to equal the previous segment's position. Okay, so its pos equals, I've got a feeling that will go wrong if I try and copy an entire vector object. Let's just do the components individually. So it just needs to, its x component of the vector x. I shouldn't be talking, I should just be coding. I'm trying to give a fairly coherent commentary as I go, but I'm not. So I've done that for the x, now I'm going to do it for the y. That's as much commentary as I can manage right now. So I minus 1 position y. So I've copied the segment in front of this segment, that position. Brilliant. So that moves the snake. Actually, that moves all of the segments, including, I'm trying to move the head of the snake, which I can't do because there is no head of the snake. Sorry, there is no segment in front of the head of the snake. So once we've done that, now for the head of the snake, like a big grin there, 3 minutes. I want to say this segs 0 position plus equals, now we'll have a movement direction vector, plus equals this direction. I can't just add it on. It's a vector position add this dot direction. Okay, that should work. But I haven't got a direction. Let's add a direction. So this direction equals create vector. I'm going to have our snake moving to the left. So that will be, this is what I did last time. I had an x and a y. So it's going to be minus 1 in the x direction and 0 in the y direction. There we go. Create direct vector. So it's got to be this direction times 20 really. Let's just do this via its components. So this position plus equals this direction dot x times this dot. We need to know the segment sizes up here. Okay, this dot size equals 20. So that's kind of bad because I'm writing that twice. I need to really inherit that from this snake. Can I do that from this snake? Can I say this dot parent dot size? That's a little nicer. I don't know if that's going to work. I still don't know if I can have a whole object stored in this variable. So, oh no, only a minute left. I haven't even got input yet, but we've got this direction times this dot size. Okay. This is, if anything else, this is exciting for me. In the middle of the night, talking to myself. Here we go. 1 minute exactly left. Okay. Well, we should at least have a snake. So we've got to say on screen, var snakey. What do you call a snake? I don't know. Peter, Philip, Angeline. So I'm going to say Angeline equals a new snake. And what do you have to tell it? I'm going to tell it to be in the middle of the screen, her in the middle of the screen, height divided by 2. How many segments? We'll go for 3. There we go. And Angeline dot, what do I say? Move. There we go. And Angeline dot, now I need to, 8 seconds. I need to include in move, I've got to get every segment to draw. Time is up, but we haven't got an alarm going off. That's weird. Anyway, unless you can hear it really loud, I don't know. So I've stopped the timer, I think. Okay. So I failed. I tried my first like speed code, and it's not worked. So we've had 15 minutes plus my little intro. So God knows. So let's keep going. We'll keep going. So number 1 failed. Right. We've got Angeline. Oh yeah, we were trying to draw her. So in move, we've now got to refer to each of our segments and get them to render. So we're moving all of the segments and drawing this one. It would be, we'll have another for loop down here, shall we? We'll say for, I'm not going to do for each. I don't like those. I is less than this dot segs length I++. So we're iterating, we're just going through all of the segments that we have. So this segs I render. So when we move our snakes, the segments in our snake, they also get rendered. Okay, so when we move Angeline in every update, we also get those segments rendered. So background, I'll keep our lovely pink color. Okay, here we go. So we should have a few bugs. Oh, Angeline, did you see her? I think she had three segments there. I think she was working. Okay, Angeline. I know a horrible solution. We'll only have Angeline move a few times per frame. So if frame count is a keyword you can use in P5, which, well, guess what it does. So if frame count modulo, I think 10 is quite nice, equals 0, then move. So essentially what we're doing is only moving Angeline every 10 frames. We're also therefore only drawing her every 10 frames. Which is a wonderful illustration of why you should keep these functions separate. Right. Why do I look at the camera that way? Sorry. Let me do that. So we've just copied that from there, and we'll have render segments. Shiver my timbers and render my segments. There we go. So only move Angeline every 10 frames, but always draw Angeline so she doesn't flicker. Render me segments. There we go. Do we have Angeline moving more slowly? Lovely. Did you see the way she uncoiled? Let's just add loads of segments when we create her. There we are. Here's a number of segments. Yeah, let's have 30. Let's use our object-oriented power. Look at her go. Look at it. Now it's not satisfying because, oh yes it is, because we do still see her moving. But there you go. There we go. I've got to do more. I've got to do more. Okay. I'm just sorry. I'm just thinking in my head. What might you get out of this video? Watching some guy fail to do snake in 15 minutes, and then ignoring the timer anyway, and just ploughing on. So I guess if you watch that first 15 minutes, at least you saw me almost make snake. What are you watching now? Why I need to get the snake moving around. It would look really nice. And as I think I mentioned earlier on, because we're OOP, object-oriented programming here, with classes and things, we could have loads of snakes dancing around. That would be really nice. So, can I put on a time? Let's put on another timer, and I'll just say I'm allowed 10 minutes of playtime. 10 minutes to do something. Now you've got to watch me try and remember how to use this timer. So 10 mins, go. Is that how this works? Yes, and it's in pink apparently. That's a good sign. Okay, the timer's on for playtime. Right. What was I doing? Input. So we need input. I should make kind of like. I shouldn't make static methods and like a utility class for controlling the snake. I will allow myself to do some hard coding. Right. Okay. What do I do? function key is pressed. Key pressed. I think that's it. Yeah, lovely. Or could I do no? I was gonna no. Key pressed. If key is down and then it's in parentheses. If key is down, we'll say down arrow. Then do this. I haven't written my add segment function yet, but I think that's fairly easy because I've done it essentially in a constructor function of when we create our snake. So copy and paste it, copy and paste that later on. 8 minutes to play. Okay, so essentially what we're going to do here, this is going to be really similar to my other code. I'm just going to change this snake's direction. Okay. Right, so I'm just going to hard code which snake we're talking about. Angeline, your direction equals your direction x. Here's a tip. I found that when you try to manipulate P5 vector objects all together in one big clump, it sometimes goes wrong. No, that's not a tip. That's basic. What I should say is, unlike me, actually learn how to use the vector objects in P5, or don't. Unlike me, just manipulate each component of it like ordinary variables. So the choice is yours. The choice is yours. Angeline direction x equals if you're going down, it's nothing. Angeline, it's nothing. Let's copy that whole thing. I don't know why that happened. I must have pressed the wrong key. Right. But if you're going down, you're going +1. If we're going up, we are going -1. Okay, I'm moving a little faster. If I'm going right, I'm going +1 and nothing in the y component, and I'm going +1 there. Oh, sorry, I'm doing the left arrow now. So I'm going -1 there and 0 on the y component. Okay, just over 5 minutes. Yeah, I'm kind of taking my time. So Angeline's direction, has that already affected the way Angeline moves? Oh my god, that's almost magical. And look, I've got 30 segments. So she's kind of unwinding. I'm saying that's almost magical because the functionality was already there, and I've just changed the direction attribute of our snake. It feels really wrong to go over your own body. Really wrong. Right, what I didn't do in the previous tutorials was even have a piece of fruit or whatever it was that the snake ate. So let's create that. Let's have another class over here to deal with that, and then we can add our segments in a more meaningful way. It's going to have class fruit, I'll call it. What else could a snake? Oh, that's weird, because a snake is, you know, the Old Testament snake associated with eating the apple. No, it got Eve, didn't it? Eve to eat the apple. Maybe it should eat. What if the snake ate sin? Little sins. No, that's weird. I don't know. That's theological. Don't know. What could it eat? It's important. I'm against the clock. But you know, it shouldn't all be about coding. It should be about, you know, what message, what message are you communicating? I'm gonna say snake is gonna eat. What could it eat? Numbers, prime numbers. Yeah, prime numbers or something. Edible number. An edible. Nedible. That's a number that's edible. So a nedible. There we go. Sounds like inedible. An edible. Constructor. Oh no, I don't know what I'm doing now. Constructor. Your number is gonna, so it's gonna be a number, and it has to be, and it's gonna have a random position on the screen. So we're just gonna say this position equals. Look, I'm making another vector which I don't know how to handle. I can't handle them, and the vector's going to have an x and y which are going to be random. So let's use math random, which is not a p5 function. It just returns a number between 0 and 1, and that wants to be scaled up to the width of the screen, and then the equivalent for the y, and scaled up to the height of the screen. And this this number is going to equal num. So I'm imagining outside of the class I'm going to increment that. We could have a function that does that, I suppose. Should we write that? Increment me. This num plus plus. There we go. So that's all self-contained. And then we need to render. I kind of want to call that print because it's not really a spritey thing. So print, and we're going to simply say text. Num. You're wondering why I'm putting the quotes in there. I'm just paranoid that it won't work if I just try and put a number variable, an integery floaty variable where a string should be. I don't know. It probably would work. This pos x, this pos y. So the text function is a p5 function which takes the text that you want and then the position. You can put other parameters for like making a text box with it. That's all you need. I think. There we go. So we've got an edible. Maybe it should be responsible for seeing if the snake goes over it. So what could it take in? The head of the snake's position. So a vector maybe. So this dot check eat. So it's got to take a snake, and we'll just grab the snake's head because that's its position. Yep, snake head. That's about it. So we've got to do some collision detection. Oh no, right. If this dot if this dot pos. Wait a minute. We need a distance between the nedible, the fruit's kind of position on screen, and the head of the snake. So we need the distance, and we get that by subtracting one vector from the other and then getting its magnitude. So let this dot so we need the p5 function vector sub, and we're going to subtract, doesn't matter which one, but this position from the snake's position. And that's just going to be the snake's head. So that's the bit that does the eating, so that's okay. Can I have some more playtime? No, I'll just... Nah. Mom, can I have some more playtime? What we're doing? I'm trying to make a function here. There we go. So let distance, let dist equal that, and we're going to say if this if dist magnitude is less than, how big is the snake? I can refer to the snake's size there. Oh, wonderful. Then eat me. Time's gone off. Okay. Right. I'm just going to put that on so I know how much indulgence I'm allowing myself. So now this, you shouldn't be watching this part of the video. You should have left a long time ago. You should have seen me fail and unsubscribed, and then go and watch something good, or even better, read something good, or even better, go and lay in the sun, or even better than that, lie in the sun. Anyway, what am I doing? This is for me now. This is just for me. I'm going to eat the apple. So collision detection. If we're close enough to that apple, nedible, sorry, we are going to eat it. So what does that mean? That means we can just increment ourselves. Sounds fun. We're gonna increment me, which I do by calling increment me, this, and whose increment, this object's increment, and then reposition myself. So can I just say this position equals, let's do it through each of the components, equals, I kind of want to kind of destroy this object and then create another one, but we'll just create the illusion of that. I should have another function to carry this out, all of these steps. And you saw the benefit of doing so when we had the previous flickery snake bug, flickery snake gate, which was great in illustrating why you should do this. I'll have to remember that if I ever want to teach anyone anything. So this pos.y equals math random height. Cool. So it should increment itself and all of that jazz when it gets eaten. Oh, and we need the snake, of course, the snake to get longer. So we're going to say snake add segment. Yes, so it doesn't actually do anything, but we had set it up. So, oh, I lost the timer there. I wasn't trying to hide it on purpose. Right, so I've had 3 minutes in addition to the 10 minutes that I've played. in addition to the 15 minutes. No, that doesn't sound too long. That doesn't sound too long. Certainly under an hour. God. Oh no, I was just thinking, I wanted to make this video so that the actual time would be very short, like 15 minutes or 20 minutes in the video that you could see, so people might, think, oh, I've got 20 minutes to spare. I'll watch a snake coding video. But now they're going to see like an hour long, 2 hour long video, and they won't see it. So I don't know. Anyway, add segment. Where was that? Was it just a dream? No. Here he is. So all I want to do is push a new segment onto myself. So this dot segs push. I would like a new segment, please. And the first parameter told it who its parent was. You know who its parent was. Adopted or not, I'm your parent. There is love exchanged between us. So this and then this position. This all seems a bit redundant now-ish. I don't know. There we go. In the sense of redundant, in the sense of repeating. It's always. I think a segment's always going to be where the head is, and it's going to always have this parent. Oh, but we do need to pass it in. We only need to pass in the parent. We don't actually need the position, because we could take that off of this snake that we've passed in. Anyway, that's the design feature that my future self will take care of, not my present self, who's just playing around. Right. So we've got an edible. We haven't tested that yet, but it should kind of keep score now. Should have a number up here, keep score. We can move the snake around. What I wanted to do was create new snakes when I click the button. The mouse, right? Function mouse pressed. So this is a P5 function, mouse pressed, just like key pressed is a P5 function. Every time those events happen, they'll be called through P5. So mouse pressed. I want to say. So I need a snakes array now. So let's have var snakes equals an array, and all we want to do is push a new snake onto that array. Snakes push new snake, an entire snake object. I've forgotten the parameters that I need for a snake. A number, so an x and a y location, and the number of segments. So we're going to say the mouse x, this keyword mouse x and mouse y is again the brilliant P5's way of storing where the mouse is for easy input and stuff in interaction. Mouse x, mouse y, and the number of segments. Should we have a random number? Yeah. Well, you have to code it. You can't just say yes and then it'll appear. Random between 1 and 100? No. We'll go, my favourite number, 9. I'll have 9. You can have a random amount of 9, including 0. So plus 3. You've got to have at least 3. Or maybe a baby snake would look cute. Let's try 1. And it might flush out some bugs if that's not enough. Right. So to make new segment, so we wouldn't see those. So we have to draw them in our draw loop. So Angeline, you'll move. We'll move all our snakes together. So Angeline will move. But then we want our snakes to move. So for let I equals 0, I is less than the amount of snakes we've got. And I is going to increment. Always happens in a for loop, unless you're decrementing. What a weird thing to say. And then we want those snakes to render. Did I call it? No, move. But be rendered every single frame. So in a similar way, down here we'll have a for loop, and instead of asking them to move, we'll render me segments, shiver my timbers. There we go. So we should have loads of snakes if we click loads of times. They'll all be kind of moving left. So I should have some AI written on there to have them like wiggling around. Or they should all, or in mouse press, they should all move with me. Oh, that would be cool. That isn't too difficult to do. I won't do it here. I'm definitely going to finish the video in 1 minute and 50 seconds. So we just need to get the fruit. So we need some fruit, an edible. So we'll call our fruit Eve. What a twist. Eve. And I better hurry now, because I'm going to have to debug surely. So Eve equals new edible, and just a number. So we'll start at number 1. I'm going to pick a random place automatically. So all I have to do in the draw loop is draw that, what's it called? Eve lowercase, increment me this. How do I, print. I didn't call it render, print. Right, run. See if we get any bugs. Yep, we got a bug, it won't run. So maybe I've missed a parenthesis somewhere. Unexpected token 158. Oh, 50 seconds. It's exciting again. It's a good finish, an exciting finish, although it's not going to go well. This check eat P5 vector. There's a 158 on this line. Oh, I don't need, there we go, ES6. I can just write there. The function name, you don't need this dot in front of it. So this is not good either. We've now got no snakes. Where's the other bug? Num is not defined, 155. I bet I've missed an underscore, is it? Oh, this dot num. There we go. Oh no, 5 seconds. It's too exciting and too disappointing. Okay, we can make new snakes. That's brilliant. But I don't see any edible. I don't see an edible. There's no bugs. I just don't know where edible is. Let's just quickly. I really promised I was going to stop the video there. I will. So let's just run through. So we make an edible. Just give it a number. This position is a random width, random height. That should be fine. Text. Let's just try giving it a text size of 64. Oh, there we go. I missed off the Y component. Well done if you get year. Well done if you spotted that. At least our text will be bigger now than it was before. Although that'll make the collision detection look rubbish if the collision detection works at all. So the collision detection doesn't work. But look, don't be distracted by that. Or rather, be distracted by this. Be distracted by the fact that I can make new snakes. Okay, so the collision detection doesn't work. I've got a feeling of what it is. I don't really know. But there you go. What a big failure. But I can make loads of object-oriented snakes of random lengths. There we go. Lovely. Lovely. Enjoy. I might put this on CodePen so you can enjoy the code. Thank you very much for watching. If you got to the end, well done. You should get a prize if you got to the end. Brilliant. There we go. And now I'm going to find out how long this video is. I'm really scared. Please be under an hour. Good night.